Let's add a little bit more detail to these tropical extratropical interactions. We looked at this where we said the extratropical waves, barotropic waves, precede the tropical convection in the West Pacific, and then they follow the West Pacific convection as well. Now you have to imagine that the convection is during an MJO, for example, is phased to originate somewhere in the West Indian Ocean, propagate eastward, come over to the West Pacific, and then disappear here over colder SSTs in the deep tropics. But there are off-equatorial convections in the ITCZ region, and then there are also convections over here. So lots of such studies have been done. This is another example showing without any filtering, they just do simultaneous correlations between the area averaged OLR and grid point 500 hectopascal geopotential height. So they are using the 5-day and 10-day mean daily anomalies between 1974 and 1982. The anomalies are deviations from low-pass filtered daily climatology. So they are just anomalies from the low-pass filtered daily climatology, not filtered with the 30 to 60 day kind of thing. However, no filtering is applied to anomalies. So you can see that when you average, so you are looking at the North Pole here, and here you have North America and Asia. So you have the Pacific sector and the Atlantic sector, and you can clearly see that the tropical convection has this correlation pattern. OLR is of course convection, so a positive here means, well, these are correlations, so one has to be careful. So you clearly have tropical convection affecting the mid-latitude intraseasonal time scales, and this is the same thing at 10 days, and you can see the signals are a little bit more robust here in terms of amplitudes. This one, this one, this one are all amplified. So clearly there is a tropical convection diabatic heating that is sending waves, which we already mentioned, and a more detailed lag relation between something like the North Atlantic oscillation, which is generally considered a stochastic process with very little predictability, even though the literature keeps evolving about whether the ocean coupling is needed or if it's just atmospheric internal variability and how it is related to the Arctic oscillation and so on. So what we are looking at here is lagged percentage probability of the NAO index with respect to each MJO phase and lag. So here lag N means that the NAO lags the MJO of the specific phase by n pentads. So you remember that the phase of the MJO itself is starting in the Indian Ocean, Western Indian Ocean, Eastern Indian Ocean, Maritime Continent, West Pacific, and so on. So the waxing and waning of the convection and moving heat source. So essentially you have to think that the MJO teleconnection takes about 2 weeks, and then the heat source moves, sends another teleconnection. So essentially you have multiple waves coming in from the tropical MJO moving heat source to the mid-latitudes, and they can have constructive and destructive interferences to produce responses in the mid-latitudes. So that's what you are looking for in some sense. So here we are lag 5, 4, 3, 2, 1, 0, and so -5, -4, sorry. Lag 0 is when the lag 0 is of course when MJO and NAO are in phase. So you can see that the phase of the MJO and the impact on the NAO can be negative or positive. So the positive values are for upper tercile and negative for low tercile. Values shown are only for those that are significant at 95% level according to the Monte Carlo test, and so on. So values greater than 45 are significant here at 99% significance level, which means that the relation between the moving heat source of the MJO and the phasing of the NAO with a MJO and the phasing of the NAO with a few pentad lag, which is very much the intraseasonal time scale, is very robust and significant at a very high level, which confirms this tropical extratropical interactions. A lot of the studies originally just focused on the boreal winter season because MJO is being studied for a long time. It's got a very robust signal in tropical convection as well as the teleconnections to the mid-latitudes. But now more and more studies are also looking at boreal summer intraseasonal oscillations. So the tropical convection during boreal summer are looked at in these boxes, the ocean boxes, these monsoons of South Asia, West North Pacific, and the northern North American summer monsoon, and so on, are looked at in this paper that's linked here. And I'm just going to show the figures so that you can see that the teleconnections are again quite robust from the tropics to the extratropics, and there are relations where the extratropical waves can precede the convection and then follow the convection as well. The regressed intraseasonal anomalies of OLR shaded in watts per meter squared. So positive again is suppressed convection and negative is active convection. So this is our local Hadley cell and the active break phase transition of the Indian summer monsoon, which you can see here. And the geopotential height 200 hectopascal in meters against the Indian summer monsoon, West North Pacific summer monsoon, so West North Pacific summer monsoon, and the North American summer monsoon circulation indices that are defined in the previous figure. So there are statistically significant regions where there are these gray shadings. Okay, so again, tropical convection in each of these boxes is able to generate very large scale, planetary scale, intra-seasonal signatures, and both for winter and summer these have been converted into heating and rainfall and river runoff, cold waves, and various other phenomenon that we looked at in terms of MJO teleconnections earlier in the last podcast. So this is from the same paper showing the regressed intraseasonal anomalies of OLR and geopotential height at 200 hectopascal against ISM, WN, PSM, and NASM convective indices. So this is the circulation indices, and this is with the convective indices. So again, significant large-scale mid-latitude responses in both hemispheres. Okay, it's not just the northern hemisphere. Even the southern hemisphere here has a very good, very solid, robust, statistically significant signature of perturbations or response to tropical convection, intraseasonal variability in the boreal summer. So both boreal summer and boreal winter intraseasonal variabilities in the tropics are influencing high latitudes, and high latitudes are responding to low latitudes but also feeding back. So we will look at more details as we go forward with other teleconnection mechanisms like the blocking patterns that develop in the mid latitudes and persist for some time, and they begin to steer the mid latitude Rossby waves, which are constantly generated by the storm activity, which is seasonal, and also the storm tracks waxing and waning, and Rossby waves breaking and inundating the tropics and affecting the MJO timescale convection and so on. Okay.